Hello there, Evie here. Today we're checking out the SilverStone Lucid Series LD01 Micro ATX tempered glass case from SilverStone. Speaking of which, SilverStone did send this to me, so this is a review sample that's been sent over for free, and I get to keep it as the process of doing a review. So if you feel that's going to skew my judgment of this case, or how it performs, that sort of stuff, then please feel free to skip to a different review and find some other information. I have tried to make this the most comprehensive and probably complex and detailed review online, so hopefully you'll get pretty much all the answers you could possibly get from this review, albeit this is a long one. Speaking of which, if you want to skip to any particular part of the video, please go down to the video description or the first pinned comment if you're a mobile user, and use the timestamps I've carefully laid out to go through all the various bits that I cover in this case. Not super detailed like when I install the power supply unit, but when we get to the unboxing, build segment, any issues that come along the way, that sort of thing, I will put all down there so you can skip to those now or at any time through the review. I'll talk about affiliate links and that sort of stuff and support for the channel at the end, so we're going to keep this intro nice and short. But apart from that, I think that's pretty much it. Oh yeah, and the system did completely die after all the testing was done, and pretty much about 2-3 hours ago, and I spent about an hour and a half trying to fix the damn thing. So I will include a little bit of that later on, as well as a little bit of b-roll with the thermal testing and that sort of stuff. So thanks guys, I'll catch you in a second to start off with the unboxing, and I hope you enjoy. Okay, starting with the box, well, it's a box, but there is a download manual prompt at the front which you can use to get the manual with your smartphone's camera. The manual is itself a work of art. Well, okay, not really, but the diagrams are clear enough with good explanations like when to route certain cables at certain points during a build, pin diagrams of the front I/O connectors, clearance explanations, and maintenance advice, including a positive pressure tip to reduce dust buildup on components like your graphics card. Speaking of which, if you've owned a SilverStone case, you may be familiar with seeing this image. But graphics cards don't really look like this now, and while it's familiar to see this, it could do with an update. Moving on to the unboxing, I couldn't find a knife, so a wooden skewer had to do. Inside the box, protection-wise, we're looking at expanded polystyrene, which is cheap and popular, but not as impact-resistant as closed-cell polyethylene foam found in other premium products. There's also a bag to prevent scratches or marks on the sides of the case. With the packaging stripped off, we're left with the raw LD01 out of the box. I'll be leaving the protective film on the glass for now, but you can check out some fully finished shots later in the b-roll. So let's take a tour of the case inside and out before we get on with the build. Starting with the front panel, there's not a lot to see apart from a sheet of glass, but there is some stainless steel trim that holds the glass in place top and bottom, something I've not seen on a case until now. Also at the bottom is a panel handle and an unrestricted intake. Eyeing up the butt joint connection between the glass front and side panels, we get to the top where we find a mesh covered intake, which is acting as much as a guard as it is a large particle filter. To the right we caught a glimpse of the power button, but to the left we have the microphone and headphone jacks, 2 USB 3.0 ports, and a Type-C port, which on a closer look seems a little bit phoned in last minute, but it's not likely to be a deal breaker. Along with the top front intake, we have a top filter, which is also designed for intake. More on that throughout the video. Up here we can fit a couple of 140mm fans with a 280mm radiator, but keep an eye on the overall thickness of your top mounted cooling solution. SilverStone only recommends up to 55mm for a 280mm radiator, including fans up top and in the front for that matter. There aren't any suggested limits for 240mm radiators with fans, but that to a large degree will come down to the internal components like those used in the PCI Express slots on your motherboard. The mesh filter itself is magnetically applied, which is pretty common practice now, but it's not problem free. To the back of the case we have a typical bottom mounted power supply unit, and above this we have an unusually placed 120mm fan position and a centrally placed motherboard rear I/O. And up top we have 5 PCI Express slots, so you could go for a dual slot card in your lowest or highest motherboard PCI Express slot, depending on the way you look at it. I wanted to take a second to take a closer look at the stainless steel frames to the glass panels. They're more than just a visual inclusion, and they act as part of the retention mechanism for the glass side panels. Now, removing an unusual panel design is always a little strange. I didn't fancy dropping the panel or using a technique that would leave fingerprints on the glass, so I decided to be overly cautious. But after spending more time working with the case, removing these side panels just requires a flat grip from the top and the bottom, and a small slide to the rear. It's really not a problem at all. I'm just making it look really awkward as a first try. A look inside of the panel, specifically at the rails, shows a small linear guide to the inside edge, and an array of hooks that correspond to slots in the chassis. Something that doesn't come across is the reflectivity of the steel, with the film still applied from the front, and you can see here that the autofocus I was using to update the focus range in this shot really struggled to understand what to focus on when the guide rail stopped at the edge. Anyway, onto the other glass panel. This can be removed in the same manner as the first. The front panel, like most, just takes a firm pull from the base. Now, this isn't a problem here like it was on the PS15, since there's no I/O attached to this panel at all that could get ripped out, but it doesn't seem like the most durable solution, but it's durable enough for the job. Now let's take a closer look at that front panel. The main build of the panel is plastic, which forms the opening for the glass pane, and the plastic clips are jotted around the perimeter to hold it to the chassis. The top part of the panel looks like it's missing a 5.5-inch drive slot, but it's more likely that this is allowing for the inlets and outlets of a radiator. There's also a top filter / guard, which is only held in place by some extended tabs, so you could easily get rid of this for a little more airflow. Underneath this is a couple of internal screws, which can be removed. This releases the front glass panel, which is also sitting on the base of the opening, guided by the stainless steel trim. This to me looks like a textbook opportunity for modding, but I can't speak for how easily it will be to remove the glass from the steel trim and maintain the condition of the blackout strips. As for the front filter, this one's a little unusual. I don't think I've worked yet with a case with a filter as thin as this. Now I don't know if this shows to a lower or higher level of resistance, maybe the testing will help us out later, but to remove the filter there's a handy handle to the left side. Now my instinct was to remove the panel like it was hinged to the right, but a straight pull or slightly right pull doesn't do a lot. Instead, a quick pull straight and left disengages the left plastic clips and frees up the right side as well with very little effort. This filter can then be replaced after slotting the right side in and pushing the left clips in place. Seems like a good design to me. As for the front of the chassis, we've got room like up top for a 280mm radiator with the same caveats, but I don't see a reason why you couldn't go for a 70mm radiator and fan unit here, as long as you have the graphics card less than 300mm long. That 70mm limit is dictated by the permanent basement shroud, and when I say permanent, it is riveted in place, so sure you could get a drill out if you want, but that would mean you'd be getting rid of this really nice placed grommet, which allows the EPS and fan connectors to pass through the shroud. To be fully transparent here is a shot of the internal rear of the case, but we've already covered the fan and PCI Express slot positions. Same goes for the top, just remember the 55mm radiator and fan limit for 280mm units up here. But the sky, apart from the population of motherboard PCI Express slots or USB 3.0 connectors, is the limit for 240mm solutions, since there's no fear of clashing with the motherboard heatsinks, since it's an inverted case. With regards to the front I/O, there is a black PCB to the right, which is nice, but the power switch has a couple of exposed pins. There's only 3 volts running across these pins, but voltage isn't really an issue here as much as amps are with regards to pain and tolerance, and I have no idea how to test amperage properly with a multimeter, so it's probably best that I say just don't touch these pins. Onto the motherboard tray, there's a left flank that has some really well-sized grommets, and the cable management loops for the rear. There's also a huge gap up top for large amounts of cables to be routed down the riser, and this bracket can be altered to support a long graphics card in a few slots in your motherboard. There are actually 2 main fixing points for this bracket, but the screw hole is a slot, so you can vary the height even further. There's not a huge amount more going on around the front, but it has to be noted that this motherboard tray cutout for access to the rear of the socket is well oversized, and that's not a bad thing in any way. This means this case should allow pretty much any CPU cooler on any sized board to be replaced without removing the motherboard. Anyway, to the right of the motherboard tray we have the cable management riser with a couple of included Velcro straps, along with some well-sized loops to fix them too. Now think back to the front I/O, we had 2 USB 3.0 ports and a Type-C port. This gives us 2 USB 3.0 connectors to deal with to take advantage of that I/O, or in other words, a potential problem if your motherboard doesn't have 2 USB 3.0 headers. More on this later. To the upper left behind the motherboard tray we have a couple of positions for the 2.5-inch drives, and hiding away in the corner is a small hole through to the front, potentially useful for a fan or audio connector to pass through. Back to the 2.5-inch drive panel, it's only held in place with a single screw, but it's also guided by 2 slots to the left and a nifty slot to the top right. To the lower front section of the case is a 3.5-inch drive cage, which can take 2.5-inch drives as well. These sleds, like most, are really simple to remove, and one holds the accessories bag, which we'll check out in a second. The power supply unit section to the rear is stated to be able to take between a 160 and 220mm long power supply unit. We'll get into that lower figure in a second, but the larger figure can be achieved by shifting the drive cage further forward at a cost of that 70mm radiator and fan maximum depth I mentioned earlier, at least to the lower part of the case. While we're down here, we can see the power supply unit, which can be removed from the rear like many of this design do. For some reason I decided not to show you, but to be fair, I was distracted by the out of place rubber pad on one of the plastic feet, and while I was correcting this, I uncovered the screw that holds the foot in place, so you may as well know it's there too. Anyway, with the pad back in place, let's move on to the accessories bag, which consists of the warranty document and 4 seconds of watching the saddest person set up all the screws in an orderly fashion. These screws consist of a Phillips 2 to 4mm hex head adapter, standoffs, motherboard and power supply unit screws, and 2.5-inch drive screws. 2,000 words in and we're yet to install a component, so let's fix that with the power supply unit. Here I'm throwing in the EVGA 750 G3 that Ben Cross sent over to me, and I won't let him forget it. I pre-attached the modular cables and slotted it in place, not forgetting to add the screws. Well, that was quick. Let's move on to the not so fast. I forgot to mention this is a 150mm long power supply unit, and this case is rated at a minimum of 160mm. And while that's technically possible, I'm certainly not going to recommend a 160mm power supply unit with the drive cage in this position and a 70mm clearance to the front for a cooling solution of your choice. The cables are bent sharp enough with a 45mm gap, but if you reduce that to 35mm, you'll just have to bend the cables a bit more, which is not ideal, but I suppose possible. Moving on to the motherboard, tipping the case onto its side, the I/O shield goes in without a problem, and this is followed by all of the standoffs. The test system being used consists of an i7-6700K running at 1.2 volts at 4 GHz. That's pinned down by a Scythe Mugen 5 CPU cooler, which is fixed onto a MSI Z170M mortar motherboard. Lowering this unit in as one was pretty simple, with no awkward clashes with any of the components, and adding the screws presents no issues either. I'm not going to cover all of the cable management in this case, but we'll see a shot of the finished article later. This grommet is very useful though, and normally this kind of grommet would be used for GPU power, but since this case is inverted, it's used for the EPS connector for the CPU, and this can also be used for the CPU fan cable. Now for drives, as seen earlier, these sleds are quick to remove, and the installation of the 3.5-inch drive is just as snappy. Flipping the sled over, a catch can be pressed to widen the sled. The motion is controlled by some rails, and there are a couple of bumpers preventing it from overextending. This extension allows a 3.5-inch drive to be slipped between the pins either side of the sled, which slot into the screw holes of the drive when the sled is retracted. Now this is a good system, but in my case it wasn't flawless. On a simple inspection of the fit, one of the metal pins fell out of its slot. For some reason these sleds have a metal pin and a plastic pin that's part of the cast which can't fall out to each side. I don't know why they're not all plastic pins that are molded into place, but this would be easier to manufacture and less prone to issues like this. Anyway, I was able to push the metal pin back in, but I'm not 100% confident it is a permanent solution. Either way, the drive can be slotted back into the drive cage without a problem, and if you weren't sure whether I was going to use this drive later, just check out the dust and that should give you an accurate indication. 2.5-inch drives, these I will be using. These can also be fitted to the same drive sled with the included screws. The procedure is very basic, just align the holes and install the screws through them. That's pretty much that. Once in place, these drives can join the 3.5-inch drive in the drive cage. Doing good so far. At this point, I wanted to reiterate the sheer size of the motherboard tray cutout. I can't imagine there's a board's rear socket that couldn't be accessed through this, and small cutouts have been a problem for me in the past. Other 2.5-inch drive-wise, we now have to employ some new screws since there were only 8 that came with the LD01, or you could go with 2 screws per drive, which I think is plenty, and the only reason I didn't is because I forgot. Anyway, 7 screws later, because I previously ruined the threads of one of the holes on my 2.5-inch drive, we can slot it back in place and replace the one screw for the panel. Connecting all these drives up was a breeze thanks to the well-placed Grommet, but when it came to connecting the USB 3.0 connectors, that's where I hit snags alluded to earlier. So removing the GPU bracket poorly reveals the problem, but looking at it from a different angle does. Clearly the large 3.0 connector is not going to fit into the side-firing 3.0 header on the motherboard. Measuring the blind spot of the Grommets, they're at about 9 to 13.5 centimeters distance from the end of this board. You can use this to calculate any hits or misses with your build. So I'm having to settle with the single USB 3.0 connector, which for me I'm going for the 2 Type A ports, but this sharing between 2 ports has resulted in half transfer speeds when using only 1 port, but I'm presuming each of the 2 cables has half the data lines hooked up to result in this outcome. This actually sucks for me because when I have to transfer 64GB of footage from an SD card, for editing I'd have to wait twice as long, so for me it's much more time efficient and practical to use one of the motherboard ports on the back. Onto fans, we'll start off with the rear 120mm position, which I'm initially occupying with a 2200 RPM exhaust fan, but I'll be swapping this around as an intake for further testing later. Up top, I'm using a couple of 120mm fans as well, mainly because I'm short on 140mm fans, but I found the central row of continuous holes really interesting here, so I use those, just because I could. But there are a couple of things to note with 120mm intake fans up here. Okay, in the video description I'm going to link to a video with a specific timestamp, a past video. I think it was with the SilverStone Precision PS15, may be wrong, but when I presented the issue where you have an intake fan in this sort of orientation and a completely flat top with perforation. Basically you'll find that, well, for a start, because it's completely flat, when specific fans, these EK Vada fans are prone to this, when they spin up to full speed, which is 2200 RPM, might not be the case for 1200 RPM fans, but when they spin up to full speed, the fan blades do lift a little, which is part of the design, and will stray from the boundary of the frame. So if I simulate this now, I'm not going to spin them up now, but you can see this when I do spin them up under their own power in that video at that specific timestamp, that they will scrape at the top. Now this becomes a problem because obviously if you want to spin up these fans past, say, half speed towards full speed, then you will encounter this problem. To overcome this problem, you need some washers at each of these pieces, which becomes a bit of a pain to install. I recommend rubber ones that have an inner diameter slightly smaller than that of the screws, so that they can sort of self-support themselves when they're attached to the screw and when you unscrew and re-screw a fan in place. But it is a problem, so if you're going to use this case, budget for some washers, some rubber washers, sort of more ideally, because they can stretch to clamp onto the screw. Anyway, I'm going to add those now and add them to the front because the front has a similar problem, and we will continue. Something I also noticed is that the central fan position perfectly aligns with the magnetic strips on the filter, so these strips ride on top of the screw heads, which tarnishes the desired flat look. And because I'm incompetent, I either lost or forgot, I'll let you decide, the footage of installing the two 120mm fans in the front. They're used as intakes, by the way. Maybe it was the vibrant red colour of the RAM that distracted me. Next up, the graphics card. A simple removal of the slots to the rear was helped by the chassis cutout. Then the card, in this case the Test Systems GTX 1070 at 2000 MHz, was slotted in and secured in place. And we can take a swift look to the back of the card to add in the graphics card support bracket, which I definitely think is beneficial for transportation, but a 3D printed bracket to hold the top in place as well would be even better. An idea for you guys, maybe, not necessarily SilverStone. Now we can fix all the panels back in place and get on to some thermal testing. I'll slot some B-roll footage in just behind the test results before I get into the closing thoughts conclusion section. But just before I started the system up, I of course had to hook up everything to the rear I/O, and in this case the graphics card. But due to a couple of rivets and some bracing providing a little more rigidity and bulk, I struggled to connect my HDMI connector, which isn't all that thick, but my bulky display port connector had no chance of fitting into the right ports. However, I could raise the graphics card within the slot to help that, but this does encroach on the slot above. So if you have more cards above, they may need the same treatment. It's certainly not the end of the world, but it was something I noticed and felt that I should point out. So let's talk thermals. I tested 3 different setups, the first of which you saw in the video, with 2 intakes in the front, mainly to provide airflow to the CPU cooler and drives, 2 top intakes providing airflow mostly to the graphics card, and a rear exhaust dumping the majority of the airflow out of the case. Note that all of the intakes are filtered on this option, reducing airflow dramatically. The second test reversed the airflow direction, so we had a rear intake, front exhaust, which was going through a filter, but I think it would be unfair to test an unfiltered option, and a filtered option in a different direction, and of course we had a top intake for the graphics card. And finally I tested with no fans, so we're relying purely on the CPU cooler and graphics cards for their cooling and exhausting of all the heat. The CPU cooler was exhausting to the rear on this one, and for all tests all fans were running at full speed and the temperatures are logged in a Delta T format to normalize the result for comparative purposes. This is an all-out thermal load test, so we're using Thermark to toast the GPU for 10 minutes and Proud 95's small FFTs test to push the CPU. Here we see the stock setup with no additional fans come dead last, and to no surprise. Since this graph is ordered by CPU temperature, the front intake option comes in second place, but this option overall performs noticeably better than the technical winner by CPU temperature, which is the rear intake setup. But they were technically well within tolerance, so the front intake option is just better. The difference between the stock, which means no fans, and all-out cooling option with an all-out load is about 13 degrees Celsius on the CPU and 11.4 degrees Celsius on the GPU. So I continue testing the stock and best setup of the initial test, and we'll be comparing to the other Micro ATX cases tested recently. Note there is a case volume bar to compare the size with performance. Starting with Firestrike's graphics test 1, the LD01 is not surprisingly at the back of the pack considering its minimal intake area. Even packing it with fans wouldn't allow it to get past the larger level 20 VT, and the PS15 leads the pack thanks to its full front mesh panel. And the result is basically the same for graphics test 2. So moving on to the physics test, this looks really strange to me, but in a logical way. So you can see the all-out fan and stock fan setups of the various tested cases are separated into 2 halves, but the results are replicated. So the LD01 is hotter than the level 20 VT, and the level 20 VT is always hotter than the PS15 depending on that setup, so that's through and through. And honestly, you can see skipping through the results are very similar throughout, so we'll jump through the combined test, Unigine Heaven, Unigine Superposition, Rise of the Tomb Raider, Hitman, GTA 5, and right onto the comparison for Proud 95 and Thermark. So from here we can learn that the LD01 stock isn't awful considering there are no fans here. The level 20 VT had an 800 RPM 200mm fan, and the PS15 had a 120mm at, I believe, 1200 RPM. But it's not exactly great, and I'd heartily recommend getting at least a rear exhaust fan to dump the hot air out of the case faster than the stock setup. But when you throw in all the fans, you get extremely comparable temperatures. But clearly that PS15 with the full front mesh is noticeably helping the CPU out, even though it's quite a lot smaller. Okay, so board is completely gone. I've had a similar situation now that I have with the Hyper 212 Evo, where the standoff has actually partly destroyed the finish of the motherboard below, so it's shorting a circuit. So there is quite a large piece of God knows what that's lifted up there. I'm gonna give it a spray over with some isopropyl alcohol, electronic cleaner stuff, and see if that fixes the job. But we may have a dead board. Just check the other ones, and this one below as well seems like a problem. I'm not sure whether this is some sort of remnants from the Hyper 212 Evo issue, or this is a new problem entirely. But anyway, I'll clean this one up, attach the cooler, see if it turns on. That one doesn't seem to be around any traces, so I don't think it's that much of an issue. But the other ones maybe. I suppose this is a lesson to, I guess, anybody wanting to design a CPU cooler in the future. I would highly recommend having the screw inside for the assembly on top of the CPU to be the other side of the board, and have it rub against the back plate, not the motherboard itself, just to reduce wear and tear. But either that or the new socket designs where you screw into the socket into a metal housing obviously works a lot better than something like this. Okay, just to document the problem, the only signs of issues I had was the fact that it wouldn't post, and the easy debug LEDs were switching between DRAM and CPU, mostly on DRAM and an intermittent switch to CPU, so it's a pretty common fault. Somebody else on a forum, I think on Tom's Hardware, but said that they had that issue, and for them it was an issue with their cooler heatsinks. That's hence why I went back that far to go and check it out. But anyway, let's see if we got anything. It doesn't look like it. Nope. Nope. Okay, now I'm scraping the bottom of the barrel. I'm gonna do the same kind of thing, only with a different tape that I did with the Hyper 212 Evo. I'm gonna create a sort of layer of electrical tape over the washer that is included with this mounting thing. So the idea is that this washer won't cause any friction, but something's going on still that's causing it to wear away. So let's see how this goes. Okay, right, so next test, instead of doing what I was going to do before, which was trying to tape over the standoff, I'm just going to post this thing, or see if it will post without a cooler. It is possible, it is, you know, it won't overheat, but we'll see if that does anything. No, that's definitely gone. You see on the left it's switching between DRAM to CPU very quickly, like just then, so... yeah, there is no way that is coming back. I could try and sort out the top right bit, but yeah, it's even trying to restart itself under no power, so yeah. That's the other computer, by the way. Don't think this one's going to make any more noises. I don't even really know what I'm doing here. There's no way that could work. There's no way. No. No. No way. No way. Okay, no, I gotta stop. This is gonna overheat. Oh my god. Okay, I was gonna put the cooler on. Okay, well, I'm gonna take this post off now. You can see what I've done. But if taking this post off kills it anyway, it doesn't matter because this was never gonna be a setup that was permanent anyway. So here we have just some electrical tape that was cut, stretched over, and trimmed to suit. And I believe that's adding pressure to the board in some way that is stopping those tracers from linking somehow. I'm gonna mount the cooler, see if it actually posts, so I can actually get this review over with. Sanity check. No way. No f***ing way. Oh my god, it's actually posting VGA, that's amazing. Okay, no, turn off, I don't need it on. Alright, let's get this cooler mounted and let's finish this review. Okay, so that's pretty much it. I'm going to go through in a second the pros and cons list I've got here, and we'll go through everything I discovered, and a couple of things that I discovered later on, which I haven't strictly mentioned previously in the video, because just cutting that stuff in just becomes a little bit difficult to manage. So first thing I'm going to do is go over the affiliate marketing stuff, just ways to support the channel and pick this case up. So first things first, Amazon UK and Amazon all over the world actually. I've got loads of Amazon affiliate links in the video description, and you can pick this case up through those. It will give a small kickback to the channel if you do. I think I cover about 7 regions. I used to cover Canada and Australia, but it just got too complicated to keep on top of with all the various bits that went right. I won't even go into it. So you can pick the LD01 from Amazon in the video description, but I also want to introduce you to a new affiliate program that I've started up with, which is a UK company called Idealo UK. I think it's pronounced Idealo. Basically, they're one of those comparison websites where you can check out all sorts of tech, not necessarily computer stuff strictly, but all sorts going on there. You can pick this case up from there, and they will filter by, you know, who has the cheapest price all out with the shipping and stuff included, what various places are selling them, and you can actually get deals on there that you can't find from PC Part Picker. Mainly for me, that I've actually picked up some RAM for the editing system, which I found a deal on there, which just wasn't on PC Part Picker, and I also got my external hard disk drive, 6TB external hard disk drive for backups. I also got that from there, which I think is pretty awesome. So it's worth checking out. I have got a link in the video description to pick this up. UK people only, so it's probably not very relevant to the rest of the world. But anyway, that's pretty much that. Hope you enjoy those, and I personally find Idealo UK is actually a really ideal service to be able to check out alongside places like PC Part Picker, Hot Deals UK, and that sort of stuff. Hot UK deals. But anyway, so let's get into the pros, cons. I haven't got a missed opportunity segment because frankly, any sort of cons that you find you can probably improve on, I guess, as a company. So I'll start off with the cons. Not many cons here. So Type A transfer speeds, I went over. Yes, it drops by about half. I think the data lines are split between the two, or shared between the two, sorry, into one USB header on the motherboard. So this results in half transfer speeds with only using one of them, not using two at the same time. I measured both of them as well, exactly the same result, and that was half of which that I would get on the back with the motherboard Type A USB 3.0 ports. Probably 3.1 Gen 1, I guess, when Gen 1 plus 1. I assume. Next up, high RPM fans. If you stick high RPM fans right against the chassis without any washers or anything to separate or create a bit more of a gap, then you can experience some sort of scraping as the fan blades raise when it hits the higher RPM limits. If you're going to get this case, I just, as just a matter of course, go and get yourself some rubber washers, install those alongside them, just to make sure that if for whatever reason your system went to, I don't know, 90 degrees and your motherboard fan curve profile sort of dictates when it hits 90 degrees, you hit 100% on the fan speed, then you're probably worth getting those in advance just in case. So top filter magnetic strip position, it's just aligned over the central hole position where I installed the fans. I wouldn't have discovered this otherwise. Could do with having the strips brought in a little bit, but again, it does make the edge of the filter itself a little bit more loose, so maybe pros and cons on that one. GPU large connector clash. Yeah, that large connector clash to the back of the GPU. An issue, if you raise the GPU up a little bit and screw it in when you've raised it up, then it should be fine. It may have a knock-on impact on other components, but it shouldn't be a compounding issue. It should just be a standard linear issue between them. So when one raises, the other raises by the same amount, and it should be okay. And finally, and probably most importantly, I think to some degree, is the blackout strips to the front here. I actually discovered this doing B-roll really not long ago, so I haven't even done the editing of the B-roll stuff at this point. I actually found that if you remove and replace these side panels enough, you actually have the blackout strip does get damaged and ripped away from the inside. Not necessarily ripped, but scraped away along the line of the sort of stainless steel trim holding the glass panels in place. So yeah, just some close-up shots I'm showing you there. It looks okay when the panels are on, but you can actually still see those little bit of stainless steel poking through that otherwise blackout finish, which is a bit of a shame. And if you do plan on replacing this glass panel and doing some modding and stuff with it, I'd expect those blackout strips to just get completely completely ruined, and you'll want to get rid of those entirely before or on the planning stage, so that you don't have any surprises going into it. So pros, this is going to really extend the length of the video. Right, manual instructions, really solid, good explanations, things like, you know, I mean, they include this in all of their cases as far as I've been concerned. Well, as far as I've seen, they have included stuff like, oh, it's good to go for positive pressure to reduce dust, that sort of stuff. It's just nice little tidbits here and there, especially when it comes to, you should probably insert this connector through this hole before you install this. That's really nice to have. There's a couple of things like that in there. Not all over the place, but just some pointers here and there. Tempered glass and stainless steel, I personally like. I think it makes a really nice design, of sort of visual to it. I hate to use the word aesthetic or industrial design, because aesthetic gets used too much. It's one of those words that's bandied around. And industrial design just means design that's been sort of optimized for an industrial manufacturing process. So pretty much any mass manufactured product will be industrially designed to some degree. So yeah, I just like the design. I think it's really clean, very nice. And I do like to say on that point, RGB fans is something that works really well with this case. Not necessarily the linear strips, because trying to ambiently light the inside of the case is difficult to reflect light off and outside through these glass panels. But if you have direct light penetrating out of these dark glass panels, it works really well. So RGB fans, yes, strips, not so much. Overall build quality, I think, is a pretty solid pro. It's pretty strong, rigid, sturdy. It's very heavy, obviously, with all the glass, but I think it holds up really well, and I don't have any issues with that. 5 PCI Express slot connections. A lot of Micro ATX cases only have 4, which does potentially limit you to having a single PCI Express card at the bottom, or the top, I guess, in this case. But they've added an extra PCI Express slot, so you can utilize a double slot card in the bottom if you need it. But bear in mind, that will probably cause issues with fan placement up top. Cable management space is a really easy one to give a really good pro to for this case. There's just so much going on here. There's good depth throughout the case, but there's also this vertical riser here. I call it a vertical riser, but there's a vertical channel up here that is just really well placed, and it's got some really good grommets there to allow you to directly connect all your SATA connections up. I did have an issue with the USB 3.0 side firing connector on my motherboard, which is a bit of a pain, but definitely keep that in mind, because there's 2 USB 3.0 ports, and if you think, oh, Type-C and 2 Type-A's, that's fantastic. Yeah, but you need to be able to install it into your motherboard. So I did give you the dimensions, I think, between 9 and 13 millimeters from the top side of the Micro ATX motherboard. That's your sort of your hit zone for the metal panel, so to try and avoid that when choosing your motherboard. And I know that's really difficult because you've got to do the maths. Somebody was trying to school me on, oh, if you take into Paint and take a sort of common measurement which you can see in an image, and then, you know, replicate that as sort of a template, then you can measure things. It's like, well, yeah, obviously, but pain in the ass. Anyway, motherboard tray cutout, vast, really easy pro. It's just really large, and frankly, the bigger the better when it comes to those sorts of things. And it did help me out a fair bit when it came to diagnosing the issues that I had with this system, and I really don't think I can rely on the system, but maybe more on that in a second. Drive support, great drive support. Three 3.5 inch drive slots with 2.5 inch drive support, and 2 2.5 inch drives up in the top left hand corner up there. Pretty solid. Power supply unit and cooling options, I put that into one. You can obviously range the size of the power supply unit that you can put in there. Again, I would actually recommend going for, if you can, a 150mm power supply unit, or maybe even a 140, but 150 is probably ideal, mainly because having more space is no bad thing, and it just makes cable management so much easier. If a case says, oh, you can fit a 160mm power supply unit in there, don't take that as like a, well, let's throw 160 in. See if you can, for the same price, get yourself a 150 with the same size fan, and you should see yourself far better off when it comes to cable management. That also combined with the option for the size of the power supply unit relative to the cooling zone at the front. Remember, 70mm is my recommendation for the maximum size with the minimum size power supply unit. That sort of combines with a sort of, there's flexibility involved, is what I'm saying. Ease of installation, really solid to install on this, had no problems at all. GPU support bracket, just nice to have something to raise the back end of the GPU support. And because this is dark glass, you can barely see the thing since it's black. It'll just hold the GPU up nicely, stop it from sagging like you see in so many. I find this really weird in ATX cases. Massive case, Long power supply unit, sagging at the end. Looks awful. Anyway, decent thermals. I really think the thermals are really good for a case that's just clad in glass. Again, you won't find thermals better in this than you will in like something in the PS15 or any other like really strong full mesh front paneled case. I mean, forget something like the Q300L, the Q500L. Half of that or more than half of that front panel is just solid steel, and then you add a mesh to it, which makes it worse. I mean, true mesh. So like the H500P with the front mesh mod, I don't know what that was called, but Gamers Nexus went into that quite a lot. But again, so anything with full front mesh, true full front mesh, will perform better than this, but this is really good for the design. And that's about it. I'm gonna stop it there. Loads of jump cuts. Sorry, my mind goes trailing all over the place. But anyway, referring back to the issues I had with the motherboard, I'm really hesitant to continue using this board as a benchmarking board, as a test system, because I just can't rely on it. It's failed twice now in about a year and a half. It just seems that those traces were completely wrecked or exposed by the Hyper 212 Evo initially, and then the situation has been compounded, and the other one has been made worse by this Scythe Mugen 5. I don't think the Scythe Mugen 5 is a bad cooler at all. I actually think it's more of an issue to do with the board and the matte finish that is put on the top, which is perhaps not very rugged. So I may have to consider just completely resetting the graphs and rebuilding myself a test system with a different board. So I'll see how I think about that. I'm really not sure. But anyway, thanks so much for checking this video out. If you did like it, please like the video. Consider sharing it. There's something I never say actually. Consider sharing the video because it really does help the channel out a huge amount to get the video out there into the public so people can get the right information and support the channel if they want. Again, supporting the channel, you can check out all the affiliate links in the video description. Definitely Idealer UK if you're looking for something in the UK for this and many other different components. Just check all that stuff out. I don't think I get any sort of commission for any other component you buy other than the one that I've linked, but frankly it's a good site and I think it's worth people knowing about. And that's pretty much that. Subscribe if you want to see more videos like this one, and please let me know about your comments and suggestions in the comments section, and if you have any suggestions for future reviews in the future. Cheers guys, catch you next time, bye bye.